Higher level GCSE math students, make sure you know how to answer tricky algebraic fractions questions like this for your paper 2 tomorrow. So we're asked to show that this expression here can be written in this form where a, b, c and d are integers to be found. So whenever you have these sort of simplification of algebraic fractions questions, the first thing you want to do is look and see, can you factorize anything right off the bat? And you should always be on the lookout for the difference of two squares factorization, as they love to throw it in for these algebraic fractions questions. So if you remember, the difference of two squares is whenever I see an expression that looks something like this, so a squared minus b squared, so the difference of two squared numbers, then I can express this in the following way. That's a plus b times a minus b, right? So always be on the lookout for this. Of course, you can write this the other way around. Now, this numerator here almost looks like this because we have an x squared and some number, but this isn't quite a square number. But you'll notice that, I can factor out a common factor of 2 from this sort of top line here. So if you notice, we have 2x squared minus 32. Well, that's the same as 2 lots of x squared minus 16. And now this is in the form of, a squared minus b squared, right? X squared minus 16, because 16 is 4 squared, which means that this is equal to 2 lots of x minus 4 times 2 lots of x plus 4. Again, doesn't matter which way around you write this. So I can already go ahead and simplify this numerator over here, and that's going to be useful, for simplifying this algebraic fraction combination overall. But also the denominator, right? I have a quadratic expression here, so I can factorize that as well. Okay, so we can say the following. We can say that x squared plus 3x minus 10, right? Well, hopefully you can factor, monic quadratic expressions like this, where the coefficient of x squared is equal to 1, pretty straightforwardly, right? We're looking for two numbers that multiply to give minus 10 and add to give positive 3. So if you think about this for long enough, you can see that this factorizes in the following way. So that's quite nice. So we can go ahead and just know that we can simplify this, fraction and factorize it quite nicely to start off with. So now that I've done this, I want to go ahead and tackle what's inside the brackets here, and I want to rewrite this as a single algebraic fraction so that I can then do the division, more straightforwardly. So how do I do this? Well, I'm combining two objects here, and I want to write them as a single fraction, which means I need to first write 3 as a fraction. So we actually have the following. We have 3 over 1 minus 3 over x plus 5, right? I can always write any number as a fraction by just writing it over 1, because any number divided by 1 is itself. But then I want, to be able to sort of, subtract this fraction from this fraction. So I want them to have the same denominator. And as always, you're free to sort of multiply any fraction by, the same number in the numerator and the denominator without changing its value. And I want this fraction here to have the same denominator as x plus 5. So I'm going to multiply top and bottom of this fraction by x plus 5. So this gives me the following. This gives me 3 lots of x plus 5 over, well, 1 lot of x plus 5 is just x plus 5. And then minus 3 over, I'm going to write this in brackets, but you don't have to, x plus 5 like this. Of course, now they have the same denominator. I can go ahead and subtract them.